Welcome to a SimCenter AimSim Student Edition tutorial explaining what is and how to use the CAD import tool. 3D CAD tools are often utilized for design and not for simulation purposes. This tool allows the user to bring a CAD model into a simplified environment to extract needed information that can then be carried over and applied to a systems model. CAD import can be opened from the Tools menu at the top of the screen. The interface for the tool includes a few sections. To the left is the object tree, where the structure of the scene will be listed. Here, each of the body or bodies will be listed in a hierarchical manner from the assemblies to the pieces making up them. The top level of this will be the scene, being the center window, which is where the model is displayed and available to be worked with. The section to the right is divided into two separate windows, with the top being the object inspector. Here, aspects of an object, being position, rotation, color, geometry, and properties, are accessible and edited if applicable. The window below is titled Measurements. That is restricted for now and will be touched on shortly. The CAD used here is found within AimSim's program files, downloaded with the software. To open this, begin with selecting File and then Import CAD File. Once at the location AimSim is saved on your machine, follow this path to open the file titled cylinderblock.x_t. After importing, the project can be saved as an AimSim-specific file, which can be opened directly when needed. In the Scene window, one can navigate around the part by zooming in or out by scrolling on the mouse wheel, panning by holding down the mouse wheel, or rotating it by holding down the right mouse click. Alternatives for each of these functions is available to select from in the top ribbon, and certain views are available to select from to the left. The cylinder block CAD is represented by this AimSim model with a thermal capacity for each of the cylinders, which, to be completed, needs to have values extracted from the CAD model. The block is thought to be made from aluminum, which has a density of 2,700 kilograms per cubic meter, which can be confirmed by looking at the Material Properties section of the Object Inspector. In order to complete the parameters of the four thermal capacity components, the CAD needs to be discretized in the same manner. The Measure feature will solve this problem and begins by selecting the orange measuring tape icon to the top of the screen. This will make the Measurements window available, and to begin working within it, select the icon with the blue plus next to it. A new window will appear that starts with a drop-down for various types of measurements the user can do. Following this is a name field to label the measurement, and last is the criteria needed from the CAD to determine its value. The measurements needed to start discretizing the model are the distances from the front face of the block to each of the pre-marked sections. Change the measurement type to distance and assign the name as front face to end of first section. The From criteria box is pre-selected, and use the mouse to highlight and select an edge along the front section. The To option will be automatically selected next, which will be used to select the line marking the end of the first section, at a portion that is in line with the front one. Once done, press Measure, and a value will be displayed in the measurement window. Selecting this value from the window will display the measurement on the model for easy visualization. Go ahead and repeat this process to find the distance from the front to the end of the second and third section as well. With these measurements available, the part can be separated into 4 sections using the split body option from the top ribbon once leaving measurement mode. When the menu is first displayed, an object must be selected, being the body from the object tree. For the entity to define a cutting plane, let's select the front face that will create a red plane, but it does not cover the entire face. Fixing this can be done by unselecting the Resize Automatically option to make gray boxes available to adjust the size of the plane, or values can be entered within the Object Inspector. Once the plane is large enough, let's unselect the second option above, which restrains the plane to the face, making it possible to move it within the model. Options for the X, Y, and Z position are available, and the measurement value for distance to the end of section 1 needs to be entered into the Y position. Once done, press Split. This process can then be repeated for the other 2 measurements, creating 4 discretized sections. After making all three splits, the object tree will list out 4 bodies present within the model. The colors can be changed within the Object Inspector for easier reference. Now, it is possible to collect all of the needed parameters for the AimSim model, being masses, areas, and lengths. Opening back up measurement mode, open the Create a Measurement menu, and select Mass from the dropdown. Measuring mass is as simple as selecting the desired body and selecting Measure. Let's do this for each of the new bodies. That will be number 1 through 4 from left to right. Next will be the individual lengths of each section. Select Length from the dropdown and select any of the edges that run straight across a section. After selecting one, pressing Measure will provide the value. For the last criteria areas, let's first leave the measurement mode. The area between each of the bodies cannot be directly found within the model presently. One of the bodies must be removed to proceed and can be done so by selecting the first body within the object tree and unchecking the visible box next to it. This will make the face for the second body available to be selected from. Moving back to measurement mode and creating a new one, the area option is available and can be done by selecting the entirety of the face and pressing Measure. This process does not need to be repeated, as the area is constant for each contact point between bodies. With all the necessary measurements completed, parameters need to be brought into the AimSim model. Rather than doing this manually, let's copy a measurement while in measurement mode and then paste it into the desired field. After pasting, the value will have a corresponding tag next to it that denotes is from CAD import. For the length between two temperature points from the conduction components, multiple measurements can be pasted within it to form an expression and determine a value, though a tag will need to be assigned manually if desired. These values can also be pasted into the values for global parameters as well, but again will not have an assigned tag automatically. And with you having all the needed parameters to complete the model, this concludes how to use CAD import with SimCenter AimSim, what tools are available to you within the Student Edition, and how to translate the information pulled from a CAD model to an AimSim model to be able to run the simulation effectively and get results based off of it. Thank you.